Hey all, welcome to my YouTube channel. This is Hemant. In this today's session, we will discuss a very important concept called data science workflow. In other words, it is also called as data science life cycle or a data science roadmap. A lot of data science aspirants ask me about this question, so that is why I am actually creating this particular video. So guys, in this session, we will discuss the different stages and we will see what are the different techniques applied in different stages of data science workflow or a project lifecycle. Let me start with the first thing. Whenever we want to solve a data science project, we always start with the data. Particularly, data comes whenever you have a problem statement in your hand. So this is so important. So you must have a problem statement. So the problem statement could be with respect to any domain you're working. Let's say that I work on supply chain management, so you might see a lot of supply chain management use cases in data science, and also retail, okay, medicine, etc. So one should have a domain expertise before actually dive into the data science project. So you have a problem statement. It could be with respect to different domains. You start collecting the data. Data is coming from the different sources. As we know, data engineers are responsible for actually gathering this data. Okay, so they collect the data from different resources and give it to us. And once we have, it is always very important to actually observe the data. So a lot of observation is very much required when you want to carry out data science projects. You do understand the domain, you understand the different variables. In other words, we also call it as the features, etc. Okay, once we understand that, the next thing is to perform something called as EDA. So typically we perform this EDA, what we call as a visualization, exploratory data analysis. We conduct a lot of visualizations. We try to find some insights or some inferences. Let's say that, for example, you may check the distribution of the data, or else you might check the relationship between the different variables. Generally speaking, you might conduct bivariate or univariate kind of analysis. All right. So these kind of visualization will definitely give us a lot of informations in your data. Once you're done with that, the next process is to perform something called as feature engineering. So what is all about feature engineering? This is so important in data science, project lifecycle. When I say feature engineering, it could be encoding the features, encoding the feature, or creating some new features for your problem statements. Creation of new features, So when I say feature engineering, I would like to take a very quick, simple example over here. Let me just scroll it down here. Imagine that you're trying to solve a simple problem. The problem is something like you want to predict the premium, nothing but the insurance premium, okay, charges. You want to buy insurance premium, and your model starts predicting the insurance premium based on the age, okay, and then the region in which a person resides, and then the salary and number of dependents. Now you can consider a lot many variables over here, but I'm just restricting myself to few of the variables in this case. Okay, you have these many variables. As we can see over here, that the age is always the numeric data. Region, let's say you have something called as east, west, north, etc. The salary is also in the numeric. Okay, let's say that you get 10,000, 20,000, 30K, etc. And then the age is also numeric. You're 20 years, 21 years, 30 years, etc. And the dependents, it could be the spouse, it could be your mother, etc. Number of dependents, it is also in terms of numbers. So you can say that it is 2, 1, or 3, something like that. So what basically we do is that we take all these features, we try to predict the premium over here. So the premium could be in terms of any numbers. So whenever you have this kind of data set, it is very important to actually see the features. You have numerical features, you also have some of the categorical features here. Let's say that if you consider this particular column called region, region is like west, east, north, etc. What you'll have to do is that these region column, which is in categorical, should be converted to numbers. That is very important phase in any data science projects or machine learning projects. The reason for is that the libraries or frameworks what we have support only numbers, and your algorithm only understand numbers. A machine learning model is nothing but a mathematical model. It understands only numbers, does some calculations within it. Therefore, we'll have to actually encode it. So it means that you try to just apply some encoding techniques. The encoding techniques could be the techniques you opt. So one-hot encoder, uh, it could be the label encoder, or it could be the robust um, encoding techniques. There are so many encoding techniques what we see in machine learning. So this is out of scope of this particular uh, recording. But anyhow, so you may have to actually see the advantages and disadvantages of all this particular encoding techniques here and decide upon which encoding technique you may have to apply for your data set. That's basically what I call as a feature engineering. So which is also one of the concept which comes under feature engineering. Let's say we try to actually engineer the data, nothing but you also try to create some extra features. Imagine that you're working on a time series data. So this is one of the problems we always see when we do forecasting. So forecasting for the future, right? So what usually happens is that in the forecasting data set, you might see that the date column, okay, and let's say that the sales. So imagine that you have the date and sales, okay, the sales of woolen sweaters. Let's say that the sales of woolen sweaters, so like 100 units, 200 units, 300 units, etc. And depends on the date, you have the different dates over here. Let's say you have 210 2001, and then 4 10 2001, etc. And then you might see like 12 2020, etc. So you might see the different dates over here. So what we usually do in time series analysis is that whenever we have the data, we try to break down the data into different components. We try to grab the date, the day, and then the month, and probably the year, right? So since we actually decompose this date feature into multiple components, we try to create multiple features from this particular column. So that is typically called as feature engineering. You try to create some extra features. So these are the things that typically come under the feature engineering step. All right. So that's what we do it in this particular stage over here, the feature engineering. And here comes the very next part called feature selection. What is all about feature selection, guys? Feature selection, as the name suggests, we try to select the important features. Imagine that you're trying to predict the premium, insurance premium, and you have all these features. Let me consider another feature here, and that feature is going to be something like this. Let me choose this. And the feature is like the color of a person. Do you think that the color of a person is so important to predict the premium of insurance premium? So we may not require this color of a person to predict the premium charges, right? So it means that we want to actually remove the irrelevant variables which is not important to or which is not important or help us to predict the target column or the target variable over here. So in this particular data set, I think that the color of a person is not so important to predict the insurance premium here. So you may have to apply a lot of feature selection techniques. There are so many feature selection techniques that we usually apply in machine learning. Just to give you a few examples here, we typically use the correlation matrix. Okay, one of the statistical technique we use to see what is the relationship between the dependent variables and the independent variable. And also we might apply some of the techniques like a recursive feature elimination technique, uh, and then select k-best method, etc. So there are so many things that we see uh, in machine learning that you can use to select the best features. However, all these different techniques are having their own advantages and disadvantages. You'll have to actually look into the documentation and see, so what are the advantages of using this RFE over correlation metrics or correlation metrics over RFE and other things also, right? That's what we call as a feature selection. So this is one of the most neglected part. The data science aspirant or data science beginner, once they have the data, they try to model the entire data and create a machine learning model. So that may not be the fair approach. You should always start with the feature selection. That is a best step or the best thing that you actually do it in your project. Okay, that's basically the feature selection. Once you are done with the feature selection, you have a final data set, and you take the final data set and then you try to create a model here. So the model is nothing but a machine learning model. There are so many machine learning models available. You'll have to see their advantages and disadvantages. And I'm going to create a machine learning model here. I typically call it as a ML model. Okay, you have the ML model over here. Once you are done with the ML model, we try to actually predict the things, nothing but we try to get some insights. We do a lot of predictions here. Okay, and we see how basically your model is behaving. If the model is not behaving as you expect, then you may have to tune the model. Let me consider the next phase as tuning the model. You'll have to always tune the machine learning models. We spend a lot of time tuning the model to actually get a desired accuracy. Once you're done with the model tuning, then if you're satisfied with the model performance, then we typically deploy the model onto the production. So typically the last step of any data science workflow is like deployment. Deployment is all about like taking the model onto the server and deploying it. This part is a crucial stage of any data science or machine learning workflow, because we try to see a lot of problems arising in this particular phase, like nothing but the data drift concept over here, and you may have to monitor your model to see if the model is expecting or giving us the better results, right? So data drift and monitoring, everything comes under something called as MLOps. So this is again a trending concept in data science uh, workflow. So a scientist may have to know this, MLOps, typically the combinations of machine learning and DevOps, development and operations. So it is very much important to actually monitor and manage your, machine learning models in the productions to actually get a desired results or to achieve a better performance. Okay, that's it about this session. So just to brief you the things, we start with the problem. The data is coming from different domains. One must have a domain expertise, that is so important here. I would suggest every data science aspirant to pick one problem from different domains and start observing the data, understanding the domain, and then you perhaps do something called as EDA, visualization, where we try to find the relationship between different features, and then we go ahead with the feature engineering. We try to encode features, create some new features, etc. And then finally we go with uh, something called as feature selection. It is not about selecting all the features or all the variables in a data set. You select the important features and feed those features to the machine learning model, and you try to optimize or tune the model to get a better results. And finally, when you're satisfied with the model performance, go ahead and deploy the model onto the production. Once you deploy the model, then we try to just apply so many MLOps concept. We try to see whether the data is being changed or whether there is any drift in the data set. Eventually we try to monitor using some of the DevOps tool. All right, so that is what we see in the entire data science workflow or machine learning workflow, guys. That's it about today's session. Thanks for watching my video. If you have liked this video, please subscribe to my channel. Thank you all. Bye bye.